So welcome to the ETHTaipei Ethereum Layer 1 R&D panel. So my name is Xiaowei. I work at the Ethereum Foundation Consensus R&D team. And these are my favorite panelists today. So, so we have three client representatives and two from research side. And so like we actually all work together remotely around the world to deliver the sensing, the Ethereum code protocol upgrade. So today, I think the goal of this panel is to bridge the small gap between research and development, and also like we want to share the messages that we think they are important. Also like exchange the ideas here.
Yeah.
Okay, so our first question to the panel is, could you give a short introduce of yourself and also share like what is the is there an L1 feature excites you the most? I mean the future feature. Like we'll start with V.
I have what? Sorry. Oh, okay. So, sorry. So my name is Vitalik. I'm, the famous Dogecoin enthusiast. I mean, I guess for favorite feature, I'll focus on one that sometimes gets less attention than the others, which is the purge. So what the purge is basically it's a set of changes, the goal of which is to try to simplify the Ethereum protocol, reduce requirements for users and for clients, and basically make both the specification and client implementations simpler over time, and also help make the network more decentralized by reducing requirements and making it easier for people to participate. And I think this is super important because there's constant pressure to keep adding new things and to keep increasing the power and the functionality of the platform. But we also do not want Ethereum to be a platform where requirements and complexity keep going up. There sometimes needs to be down as well. To that end, I think one of the most underrated features of Denkun was the self-destruct removal, right? So now, as of about a week ago, the self-destruct opcode only works if you destroy a contract in the same transaction when it was created. And I personally hope that in a couple of years we can go further and remove it entirely. And the reason why even the first step is valuable is that it adds a new invariant, which is that there is now a hard limit on the total number of changes to the state that can happen within a particular block. And it's proportional to the gas limit, but at least there is an upper bound. In the past, this was not true. And the reason this was not true is because you could have a super big contract, and that super big contract could get self-destructed and then recreated, and then like you could read and write state on top of state that was destroyed. And this actually creates a whole bunch of complexity for clients that were trying to keep the state cached to try to deal with. And that's like basically hundreds of lines of code that could get deleted now. So excited about that. I'm excited about Geth recently removing a whole bunch of code that had to do with the basically pre-merge proof of work handling, and hope more things like that continue.
Thank you, V. And Marius?
I'm Marius and I like BLS.
Why do you like BLS?
No, to your point about about removing stuff. It's so great that we can finally remove some of the code from the different clients, and in the future, if we have history expiry and we don't have the requirement for clients to be able to sync the chain from Genesis anymore, or at least for some of the clients, we can have really nice new implementations of these current Ethereum protocol instead of requiring everyone to also implement the rules from like 10 years ago, and because like and yeah, implement the bugs that there were 10 years ago because they are enshrined now, and everyone has to kind of implement these weird behaviors before this block, and then after this block it's a different behavior. And so yeah, I'm also very excited about getting rid of stuff. But I actually wanted to really talk about BLS. We are looking into adding BLS precompiles into the EVM, and that is really exciting because right now, well, the consensus layer has been using BLS for a very long time, but BLS just wasn't available on the execution layer at all. And putting BLS into the EVM gives us a bunch of really cool things, like if you're depositing, you can actually verify that that your keys are correct and stuff. That you can verify the signature on your deposit. You can do a bunch of cool things that you can do with BLS, like aggregating signatures. And I think a bunch of protocols are really waiting for BLS to hit. And hopefully we will be able to ship it in the next hard fork.
Thank you.
Hi, I'm Matthew Keel. I'm part of the Lodestar team. And as a JS developer, because Lodestar is a TypeScript implementation, I come from a UX background. And I think some of the most important features in the horizon of Ethereum are simplifying the interactions and also reducing the settlement time. And this is why I'm a big advocate of both account abstraction and single slot finality, which MaxiB is a big piece of. And I think one of the biggest things, while I appreciate a lot of the technical prowess and the difficult problems that we're solving every day, bringing the next billion into the ecosystem, I think is an incredibly important piece of the future of Ethereum, and making it compatible with the thoughts of like my mom and grandma is a big step forward for how the ecosystem will evolve.
Thank you, Matt. And next, Guillaume.
I'm Guillaume. I also work for the guest team. I like adding more code so that Marius can delete it later. I work currently on Virtual trees, so that's my favorite topic at the moment. But I'm also excited about zk-EVM. I think it unlocks a lot of cool features for Ethereum, for increased usability, increased freedom as well. Yep.
Thank you. So our panelists mentioned various types of the features. So I want to talk more about the Verco. So
Who would have thought?
so first to Vitalik, so people love to investigate your roadmap diagram to find if there are like actually the gold in this. And I wonder that, I think it really helps to understand what is the ultimate goal or from the small features that will work in the 1 year and what it will grow in maybe 5-10 years. Yeah, could you like elaborate about what is the ultimate goal of Verge?
Sure. So there's a multi-step roadmap here, of which I think Virtual trees are a very important first step. But there is also a second step and a third step. And the ultimate goal of all this is to make it easier to run nodes, right? So, we talked, yesterday and today about the difficulties of being a solar staker, and being a solar staker requires having a node, and being a solar staker becomes much easier if running your own node becomes much easier, and it becomes something that has the overhead of like regular software daemons, of which your computer already has like 50 that you've never heard of, as opposed to something that takes up 3/4 of your hard drive. So that's the first step. There is Virtual trees, which we'll talk about, and we have talked about. But the main goal is to reduce the hard drive space required to have a node. That together with EIP 4444, which would require nodes to no longer store all of the history. But then there are also longer term steps. In particular, the big longer term step is ZK synarching all of Ethereum, right? But basically it wants to get to the point where the block builder would be the one that's actually generating a proof that the entire block, the state root, everything is computed correctly. And any other node in the network only needs to verify a proof, which is an extremely fast operation, can be done in ones or tens of milliseconds to verify that that block is correct. So once we get to that point, then running a verifying node actually will be something that has comparable storage and compute difficulty to the hundreds of other daemons your laptop runs without you ever learning about it. But to get to that point, we do need to still get quite a bit of work done. But fortunately, we've seen amazing progress on virtual trees, and we've also seen massive progress on ZK VM implementations. So I'm very excited.
Thank you. Anyone want to talk?
He said it all.
Yes.
I actually think one of the advantages that Verkle gives us is not like, sure, light clients is cool and all, but I think the biggest advantage is it makes us able to prove things about the state in a very efficient manner. And this can be used for all kinds of things. I think you talked about L2 bridges, and I think there are a lot of use cases, a lot of protocols that are underexplored that can make use of these state proofs. We have this idea about the light client diversity, where one of the clients is producing proofs and all of the other clients. So you not only run one client, you run 5 clients on your machine. You run one main client, and that is producing a proof for all of the other clients. And these other clients verify the proof. And then at least within the EVM, all of those clients agree. And so we have a way easier way of making sure that no bad block makes it to the network, because or if a bad block makes it to the network, it doesn't turn into a chain split, because you will only attest to the block if all of your light clients agree to it. And I think there are probably hundreds of use cases where you actually want to prove something about the state, but you cannot really do it right now because the state is so large and creating proofs for it is so large. It's not really possible. And I hope with Verkle we can move there.
I'm actually really excited about that as well. So Lodestar has a project called the Prover, and it gives us the ability to actually do full client-side proofs of individual contract state or transactions. And in order to do that today, we are actually still communicating with the EL side and pulling a lot of these pieces as you're talking about. And so Verkle is going to actually pair a lot of those proofs with the transactions, which is going to actually increase the efficiency of our prover. This is something that is actually really exciting to us. So we're something that ChainSafe is doing is we're in discussions with MetaMask at a very high level to explore feasibility of including our light client and our prover in MetaMask. And what does that do is it reduces the need to depend on external providers like Infura or Etherscan in order to do verification of what do I actually have. And so being able to reduce the amount of transmission and CPU on the client side, especially in resource-constrained locations like the browser, it really increases the usability of that feature.
Yeah, and like right now, if you're sending a transaction via MetaMask or via most of the wallets, you're kind of trusting the wallet to do the right thing for you. Yeah. And you're trusting the RPC provider to send you the correct state. And there are projects out there already that combine this with proofs in the current Merkle-Patricia tree, but it's just not very scalable, and it puts a lot of resource constraint on these bandwidth constraints on these proof providers. So if we can move to smaller proofs, you can do things like whenever I sign a transaction, I want to know that the balance that I currently have is actually the balance that is on the blockchain, for example.
Yep.
And so just getting your balance is something where right now you're trusting the provider to get you the correct balance. And it would be nice if you could, in addition to getting your balance, you actually get a state proof to it that it matches the current state rules. So.
You know, and actually one of the things we've gone even further to do is we can pre-run transactions in the browser fully client-side, but again, it requires pulling sections of the state and sections of the smart contract code and then running it in an EVM on the client side. But having these proofs that are provided by Verkle will actually reduce a lot of that overhead. So it actually makes it feasible in order to basically pre-run a transaction using live state on mainnet before you ever actually have to send that transaction. It's actually a very cool feature.
And so, just to add what you said, that I also think like the biggest advantage of Verkle is that it's going to improve trust. By an order of magnitude, you're going to be able to prove a lot more that currently you're just trusting people, to be honest. You were talking about resource constraints, so the browser is one thing, but clearly what at least I'm targeting is the Raspberry Pi. All those devices, when it comes to computing power, they're okay. They have a lot of RAM, they have a lot of computing power. I/O is the thing they really fail on, and this is going to offer, I mean, ideally, we would be validating on phones. We're not going to be right there right off the bat, but this is a goal, and I think over time it's achievable.
Thank you.
Sorry, another thing. Apologies.
We love Verkle.
Let's make it about Verkle. Okay, let's. There's a test net, right? I mean, you can try Verkle right now. You can experiment, and I invite you to do this because we want to get some feedback. We want to build cool applications. So the sooner people get on that test net, the better we make it happen.
Indeed. So about the Dencun, the protocol upgrade just happened last 13th or something, and last week. So and just 1 week, within 1 week, and also in the past months, that the client teams are very hard working at what will be in the next hard fork. So it's like hard fork, and they sometimes like overlap in some ways. The features are working in parallel. So let's talk about the next hard fork, which is the Pictra. According to Tim Beckel, it's called Pictra. And so yesterday, just a couple hours ago, that we made some progress of the two EIPs. So the first one is the EIP 7251, the Max EB. That is basically it allows validators to have a larger effective balance. So before that, the max effective balance and is actually just 32, and we want to increase that one so that the signature on the network should be reduced as well, and to decrease the overhead of clients. And the second feature is the inclusion list that was mentioned in Maria's talk previously. So I think I don't have to talk much, but it's helps the censorship resilience. So I wonder that what do you think about these EIPs? Open discussion. Yes.
What do you think about MaxiB? Why do we need MaxiB? Matthew, you're probably the best one to talk about.
I mean, to be fair, I love the fact that it's just going to reduce the bandwidth for the same reasons. It's easy enough with BLS in order to aggregate signatures. It's a relatively CPU intensive process. But just being able to collect all of the attestations in order to propagate them across the network on a global scale is really the challenge. And MaxiB is a great step forward in order to promote single slot finality.
Do you think that the big validators will start to consolidate?
No.
No?
Honestly, no.
Yeah.
And
I actually had a question about MaxiB because I only had a very quick look over it. Is it going to be possible to merge, like, do we have to exit? If you have more than one validator, do you have to exit and then push everything back? And would it be hard to actually merge validators without exiting?
That would require way more lines of code.
Yeah, but I'm fine with that in code. I'm not.
Right.
Especially on the consensus layer.
Yeah.
Right. So,
Inclusion lists.
Oh yes.
Right.
What do you think about it?
Yeah, I'm gonna rain on the parade here. I think it's important overall. I think it's a bit early to include them now. Every feature has to be delivered yesterday, but I would say we have a censorship problem somewhat, but it's not really pressing as much as other like MaxiB, because we do have some timing issues that would be solved with that. I would say, clearly Verkle because of the disk size and some features. For me, I think it would benefit from more maybe thinking through. I think it's going to delay Prague, and therefore is going to delay Verkle. And I know I sound like extremely obsessive, which I am. But at the same time, this is a fork that needs to be taken very seriously. It's on par with the merge, it's on par with 4844. So it's nice to have I would like to keep Prague as small as possible with a lot of usability features. But I'd say it's time to get to work on the big thing as well.
I'll give some. I guess I'll be the grumpy uncle and give some somewhat unsexy EIPs that I would still love to see. So EIP 7623, which puts the floor on the cost of call data of either 48 or 68. There's two versions, and that actually it leaves the gas, because it's not a gas cost increase, it's a floor. It leaves about 99% of use cases unchanged, but it reduces the bound on the block size from about 1.87 megabytes to basically 1/3 of that, so about 600 kilobytes, which makes it safer to do things like increasing gas limits or increasing blob counts. Another one is to start thinking about increasing gas costs of operations that are uniquely expensive from a snark perspective. This I think especially includes the hash functions. I think the worst offender is the hashing that's inherent in the So the more Patricia tree, but we're getting rid of that anyway. But aside from that, like things like SHA-256, like Ketchak and the various other hashes, because for the ZK EVM L1 use cases, again, we need to have very good bounds on how long it takes to prove a block. A lot of things, for a lot of things, the safety is decided not by the average case, but by the worst case. And people really love putting the average case numbers in their headlines. But like right now, a lot of the ZK EVM implementations, they're doing really ugly stuff because of the worst case stuff. Like they have ugly things like basically like having to do more centralized sequencing because they wants to have an extra layer to prevent people from putting in blocks that do lots of hashing. And like clearly the correct solution to this is to just make hashing 10 times more expensive, right? But we need to actually do it. So that's another. A third is doing the same to logs, and possibly simplifying the hashing in the logs, removing Bloom filters because at this point nobody uses them and they're expensive, reducing gas cost of logs, potentially replacing precompiles that are currently almost never used with equivalent EVM code implementations, which will definitely increase their gas cost by a lot, but it's like my favorite way of deprecating things because at least it doesn't fully break any application. But like there definitely are lots of precompiles that we excitedly edit in because yay the features, and then 5 years later like pretty much nobody uses them and they're like half our source of annoyance for consensus bugs in some cases. So start moving toward expiring those. So just a bunch of purging and a bunch of limiting.
Do you think it would be like, do you think it's realistic that this happens in the next hard fork?
For the next hard fork, I think realistically, if we want to add things, we need to add the subset of that, which is like one-liners. So I think AIP 7623 can, because lots of people are already raising the alarm that 3 blobs is not enough. And I think the only realistic and way to add more blobs that doesn't depend on amazing new technology is to improve on other guarantees. So that's one. If I wanted to start the whole train of replacing precompiles with EVM implementations, the one I would start with is identity because the implementation that replaces it is like literally less than 10 lines of code. But like if it starts later, that's fine, right? But basically, definitely do one-line things. Like I would definitely not advocate for anything bigger than like 1 or 2 line changes, just because the main stuff is so important.
Yeah.
Actually, we had a bug in the one line that is the identity precompile, and getting a bug fix for that. It was a consensus bug. It was a couple years back, and getting a bug fix into a one-line precompile is kind of it's not easy.
This is true. I mean, I guess the argument would be this is deleting a precompile, which is easy, but still, point taken.
So, like, why are we so afraid of like adding precompile?
I mean, I think the reason why we're afraid of adding precompiles, and the reason why even something as seem as common sense as like making BLS accessible from the EVM when we already use it for like a bunch of other things takes so long is basically we do have these kind of horror stories of like yay, let's have this new thing, here are these amazing use cases, and then like 4 years later there's no use cases, and then there's like hundreds of lines of spec code, right? So like the complete listing is basically RipeMD. So that one was a hash function that was added in order to enable Ethereum Bitcoin compatibility applications. Nobody uses it. Then Blake, same thing, but for Ethereum Zcash interoperability. Nobody uses it. Mod EXP, intended to enable RSA cryptography-based applications, including Plasma Prime, including like a whole bunch of stuff, possibly VDF stuff. The result is nobody uses it, and it's a big source of consensus bugs. Then, I mean, identity, but like that one was useful, but now we have mcopy as an opcode. Then, I feel like aside from those, no, I think the other stuff basically actually is like the elliptic curve pairing stuff, which we actually do use quite a bit, which is great.
But it would become obsolete with BLS because presumably all
Indeed.
the ZK.
Yes. So with BLS, I guess the BN128 focused precompiles, they would become obsolete in the sense that there are better things, but like there's lots of existing applications that would keep using them. But I mean, the time when they'll all become obsolete is when like quantum computers blow everything up, and then there's no point.
Do you think we're making the same mistake right now with adding 9 precompiles for the BLS?
That's yeah, it's a good question. I mean, I think there's a value in being pragmatic. I mean, I feel like sometimes the distinction between like adding a few precompiles and adding more precompiles is like actually not large because they're like basically pointing to just like different places in the same code base. But I mean, on the other hand, like there's times when if you add more precompiles, it ends up exposing more things that makes things harder to change later on. So one very subtle example of this that I can give is when we did the pairing precompiles for BN128, the original elliptic curve, we designed the pairing precompile specifically in such a way that it doesn't output the GT element, which is like the answer of a pairing computation. It instead, like you have to put in a series of elliptic curve pairs of elliptic curve points, and it computes all the pairings of them, and then multiplies the pairings together, and then checks if the result equals 1. And this is like one of the important things that this means is that it basically means that clients have a choice of which elliptic curve pairing implementation they build, right? Because there's like actually like hundreds of ways to do, like there's like okay, fine, at least 3 ways, probably more ways to do a pairing, and then there's hundreds of ways to represent fields, and so there's like lots of different ways to represent pairings internally, and if you had to like make them match up on the answer internally, like that would really constrain the like the implementation, and that actually open up a lot more attack surface for bugs. And actually, it would have also prevented a whole bunch of optimizations because there's actually some optimizations you can do to pairing checking when you can guarantee that lots of pairing computations are being done at the same time. So yeah, lots of lots of these kind of subtle things where you can end up dodging a lot of bullets if you open up less functionality at the start. And like this is just like one of the things that's really valuable to be careful about.
So, I would also like to answer the question about why we don't like precompiles, or why we don't like precompiles as much as maybe the L2 people like precompiles. They really love them. So you're already kind of mentioned it. So we have the mod x precompile, which does x to the power of y mod p. And within this precompile, I think almost every client actually had a bug at some point. I know that we, within Geth, had 3 bugs at least. One was in the Go standard library, where you put in some certain input and it would just panic with the error message, impossible. Turns out it wasn't impossible to hit this, so we had to fix the standard library. The other one was if you put in a really, really big modulus that was even, then it would just take extremely long to process the block. And we were like, okay, sure, what's happening? Turns out in the Go standard library, they have this nice little switch. If the modulus is even, they use this one algorithm. If the modulus is odd, they use this other algorithm. No one ever uses mod x with an even modulus. Like, why is this even possible? Because everyone uses mod x only for like cryptography, and for cryptography you always have a prime modulus, or at least an odd modulus. So no one ever did any benchmarks with even moduli. And yeah, again had to go into the Go standard library and create a new algorithm for even modulus for ModExp. And the other thing is, like, that is one bug that I think I found in at least like 3 or 4 clients, because it's like the fuzzer usually finds this pretty quickly and no one really thinks about it. With a ModExp precompile, you basically have 6 fields. You have base, exponent, modulus, and then you have the base length, the exponent length, and the modulus length. If you specify the zero modulus, then the result will be 0, because anything modulus 0 is 0. But what happens is you can specify like really big numbers, and the computer will crunch them, and then in the end apply the modulus, and it will be 0, and so the answer will be 0. And it's just like there are a bunch of times where clients just ran out of time because of this. And it's been in like most of the implementations.
Yeah, so as the author of the ModEx precompile, I apologize.
Right,
I like how Marius reveals critical vulnerability in the public setting like that.
So we have like some different preference of what EIPs, what features we like. But in reality, that there are some other considerations, like for example, like timeline and what are the users like. And how would you describe your preference based on your considerations? Like, what are the factors that you would prioritize?
So for me, I think security is the most important one by far. It should be. We should try not to create too many foot guns for people, so that they don't shoot themselves in their own foot. For example, the self-destruct create 2 thing, that was kind of a foot gun, where you could. Everyone is under the assumption that the code that a contract has cannot change. But now we have this paradigm where you can change the code of a contract. And so it's very important, if we evaluate new EIPs, to think about, does this change the mental model that people have? And does it introduce some new denial of service stuff? Like these technical considerations, but we also have to take into account some of these more, I would say, soft considerations about, like, what are people thinking about it?
That's a really good point.
And you mentioned your grandmother, right?
Exactly. Or even something like IL. This is a feature that is relatively, at least from our CL side, easy to implement. But what are the human implications and the user implications of bringing IL into effect? Like, is it just going to whack-a-mole style open up a new market for ILs and just create a new version of MEV Boost? And I think that's not really a technical challenge. I think that's more of a usability challenge that requires more study, just from seeing how the market is going to uptake this new EIP.
Yeah, I mean, usability is definitely a big factor. I would say there's also how you don't take the whole house by removing a brick or adding a new brick. So we have, I mean, unlike many other blockchains that have projects that have a higher delivery speed, we have already a lot of value logged. We already have a huge user base, and we unfortunately cannot move as fast, and it's a pain. But it's also extremely important because there's a lot of people depending on us. So yeah, that would be another criteria.
So,
Yeah, you.
no, just it's like a very big product management and we have to balance between like decentralization and also the technical consideration. Yes, and I think like sometimes for us on the stage that we prioritize security, but I think we all cherish that as the most important thing for the network. We have to be responsive to the users,
Yeah.
and I mean it's like
It can be a challenge because sometimes you have these proposals that are very short-sighted, that are made by some company that I don't know, develop some product, and they really, really, really need this one feature, and it's just kind of like we will be stuck maintaining this feature forever, forever. And that is a big problem. And this company might be out of business in like a year or two. And we have the same thing with we have the same problem with Geth. A lot where like people show up, propose some feature, maybe even write the code for the feature, and then we merge it in, and 3 years later we want to like refactor something or something doesn't really work, and then we cannot do it. We cannot go with our new ideas because we have this one feature that like 3 people in the world depend on, and we cannot get rid of it. So it's always
right.
Yeah, we need to evaluate the proposals very carefully.
How many guest folks like you can you daily talk to? Like,
I think it's roughly 9K or something, 9,000 forks on GitHub. Most of them are not like other L1s. I think so. The big gas forks that are actively maintained, probably like 10, 15. But I don't know.
So it's like a much more energy and liberation of the. You have to talk to them, and for the maintenance, it worth your time in.
Yeah,
the
it's
features
sometimes sad that there's too little collaboration. There are sometimes you go to a conference like this and you talk to someone who knows exactly what you're doing. Like they know like what everyone in the team, what their role is. They know exactly what is happening, what we're working on, and yeah, they sometimes know the features better than you know them, even though you're working on it. And there's a lot of knowledge about, especially about Geth, in the community. But unfortunately, it's very rarely that this really helps us and that this comes back. So we would love, like, it's great from my point of view. It's great that Geth has been forked so often and that so many people know how it works internally. But it would be really, really nice if some of that knowledge came back to us. So if you are working on a Geth fork, if you are maintaining a Geth fork, and you find something, you find an issue in Geth that we didn't see, report it to us, send it to the bug bounty program, get in contact with us. If you found some cool new optimization that you did in your fork, upstream it. We very heavily depend on the community to help us with new ideas.
So power collaboration in the open source community.
Yes.
Yeah, I think that's also that's a really good point. And I as a newer core dev, I'd like to say thank you to all you guys who have laid the road ahead of me. And I now get to carry that flag forward. But I think this is a great opportunity to ask the community, because we say thank you to you guys all the time. And I think it's really important that we say thank you again. But like you're saying, there is this fractioning of the space, sometimes for not within that Web3 ethos. That I think it's a great opportunity for us to say, please come back and give us feedback. And we not only are always there on Discord, we're always there in our, at the community events. We love to hear from you. And it's really important for us to get that feedback because the usability of the system is really key. And we're building it for you. And so understanding your use cases and your challenges and what other opportunities are out there, I think not only helps us to build a better ecosystem, but to really build the best product that's possible.
Good. So as a wrap up, could each of you share like one vision that keep you motivated to continue your current work?
Just one? Yeah, I mean, I would say, it's easy to get depressed when you look at all the bad news in the world. I think we have a truly unique chance of building something that is going to last forever. There's this talk by Danny Ryan at Bogota 2 years ago now, where he said Ethereum is the intellectual gravity well of the entire space. There's a lot of things happening. I would not be able to pick a single feature. They're all awesome. Most of them will never happen. There's so many ideas that fly by and come back and disappear and so on. I'm going to say ZK. Everything ZK related is awesome. If we could just improve the security, the privacy, the censorship resistance, I think it's going to have a huge social impact. But yeah, I wouldn't be able to pick a single one.
I'm going to fall back on account abstraction and lowering the burden of uptake by the next billion people. I think in order to lever this technology for everybody, I think is a huge opportunity in order to really grow not only the appeal but the usefulness of this amazing thing that we've built.
I think to be in this space, and especially in the Core community, you have to be extremely self-motivated. Like, it's way easier to make 10 times as much money doing DeFi or doing MEV or doing some ICO or whatever. And yeah, I think the vision of the future is what kind of keeps us in this space and keeps us building for something good. Like, I don't want to be associated with business models that extract the value from the users. I want to work on stuff that actually brings value to people. I want to work on stuff that I think for the longest time, companies have extracted a lot of the value from normal people, and I think Ethereum and blockchains are a way to give back some of the power to the people, and I really like that. And the other thing that I really like is that we did the merge, and we are not as energy hungry as some other orange people in the space anymore. So yeah, that was it was a passion project, and I think all of the people who worked on it worked day and night because they saw this vision of the future, and the vision isn't there yet. You have a great quote about the Internet of Money shouldn't cost 50 cents per transactions or something. And like people
The Orange people laughed at that one for 5 years.
yeah, and people clown on it, and I think it's this like this is it.
Yeah.
This is the vision. Like, no, it shouldn't, and we're not there yet. And we need to keep building until we are there, until we can provide cheap transactions forever, and not like burn out within like 5 years or something, because no one is able to verify it anymore. And you have to have these huge servers to compute anything. No, we have to build a sustainable future where everyone can transact, and everyone has the right and the freedom to transact however they want. And that's I think that's what keeps me motivated.
That was an awesome answer.
Thank you.
Yeah, I mean, I think in addition to the the money and finance aspects that get highlighted all the time, I mean, I see Ethereum as being like one of the standard bearers of the open source movement, and that's something that I have highly valued since like long before I was part of the cryptocurrency space. I can still run Linux on this laptop. It's my laptops have been running Linux for about at least 15 years now. Continue using various open source tools, and always still keep my music in MP3 files. Like always appreciate things that are actually hackable, that actually work with standards, that don't try to keep locking you into all kinds of proprietary ecosystems. And I view blockchains as being one of the extensions of that whole space of values to software that requires collaboration. So it's a software where it fundamentally is not just a thing that you can do on your computer, but where it has to involve some kind of persistent interaction between a very large number of users, right? And if you don't do that with chains, then the only practical way to do that with servers. And we see what happens when our basic infrastructure and our basic ability to interact with each other depends on servers. So I look forward to building a future that is not just that.
Thank you so much for coming to ETHTaipei, and thank you for the panel. And okay, that's it. Thank you.
Thank you.
Yeah, thank you.
Thank you. All right.